Hello and welcome to the Rubber Duck Dev Show. It is August 25th, 2021, right? I'm in the right year, aren't
Hey,
I don't know, maybe I'm in the future. Who knows? Anyway, so tonight is part 3 of our 3-part trilogy on speed. So tonight we're going to talk about infrastructure. Oh, this is the part. Look, full disclosure, I hate this stuff. I just,
most programmers do.
yeah. So, but
That's why they pay extra money to get it managed for them.
right, exactly. Um, but I do know that it's important to understand some of these concepts so that you can pay attention to it. And some of these things it's necessary to understand even from a code perspective, and we'll talk about some of those things tonight, is that the solutions to some of these issues are actually done in your code, not just in the hardware. So, something to keep in mind with this series we've done, we talked about database, we've talked about code, and now we're talking about infrastructure. But when you're looking at website speed, those things kind of cross lines. There's not very clear delineations between those. So just keep that in mind. Again, this is going to be kind of a broad strokes coverage of this topic because it's huge, and all of this stuff is going to be generalized. A lot of this depends on your language, your framework, your choice of hosts, how you've got things architected. We got a guest speaker tonight.
Yes, my apologies.
It's fine. Life is life. So just keep in mind that these things are generalized, but the concept should hold true pretty much across the board. And we're going to try to stay pretty general here. So I've kind of broken this up into 2 major sections and a bonus. So first, we're going to talk about the kinds of things in the infrastructure world that affect website speeds. Then we're going to talk about what is it we're trying to target. What are the gold standards? And then we're going to talk about ways to fix or modify those things that affect website speeds and stuff you can look at. So that's kind of how we're going to progress the show tonight. So what things in the infrastructure world that we haven't already talked about in databases and code affect website speeds? Well, one is file delivery, like CSS and JavaScript files, images, that kind of stuff, because every time a page loads, there's a whole caching discussion involved here, but when a page loads, it basically has to pull down all those files. So all that stuff you have to make your website pretty takes time. So that's something you have to really be aware of, and there's a lot of different ways to architect things and ways to speed that up, and we'll talk about a bunch of those. That's probably one of the easier things to deal with in infrastructure, because most of the time a lot of that is fixed on the code side or on the packaging side and not necessarily on the hardware side. But
So have you ever had, I've never had a problem with too much JavaScript that slowed down pages or too much CSS. Definitely run into problems with images. Not that I've produced myself, but like allowing a customer to put images on their page, they sometimes paste in images. And even though you can do some image manipulation to reduce it, if they somehow are able to upload some gargantuan image to put on their page, and then they call you up saying, why is my page slow? You know.
But you uploaded a 5 gig image to it, you wingnut. So yeah, and that's, I mean, there are some things you can do to mitigate that kind of stuff, even if you've got user submitted things. And we'll talk about some of those. And I have actually seen, now the JavaScript and the CSS usually aren't big deals, but where they'll really affect things a lot of times is the time to first render of a page. So, things like, do I load my JavaScripts at the beginning of the HTML or at the end? Time to first render, so the page takes this long to load.
Synchronously or asynchronously.
Right.
Asynchronously, yeah.
So it's usually not a big deal, but if you do have a lot of JavaScript and CSS and or images that you have to download, it is a fairly simple thing to take a whack at and get some improvements. Another thing that you can run into, that I've run into, is links somehow or other through your code, whether it's on the page or on in JavaScript or something like that, to third-party servers or services that are slow, because you have to wait on them and you have no control over them. So, linking to Imgur or some image site like that, or
any kind of ads.
Right.
Ads. I mean, your page may load quick, but then if your ads aren't loading, it looks like the whole site is slow.
Right. And that's, I get ads, but oh my God, just if you want a decent looking website, you really have to be very careful with those, especially on mobile, because they make a mess of things.
Yeah. And I mean, normally this isn't going to impact someone writing an application, but I have worked with clients who the main revenue of the application, it's a public application, the main revenue of it is from advertising.
Mm-hmm.
So the advertising is a key part of the revenue model for the application.
Right. And so sometimes, necessary evil, but that's a thing that can really slow you down. And also it can make a mess of your, especially on mobile, make a mess of your layouts and stuff. I can't tell you how many web pages I've gone to that have these ads on them, and on my mobile, and it's just video ad, one line of text. Bye. There's also, so another thing that can really affect it is inefficient or non-existent use of browser caching. You need to understand how browser cache works so that you know how to most effectively and efficiently deliver your content and all the stuff that goes with it, because caching is a big part of making the web fast. And there's, that's a whole, again, caching, like we talked about last week, is a whole discussion in and of itself, multiple discussions, but it's something you should dig into. So traffic volume is another big thing. Your performance very rarely is going to be linear with your traffic volume. What's going to end up happening is when you get 4 times the traffic, you have 8 times the speed reduction. So you get a multiplicative effect from that. So as your traffic volume goes up, you're going to have to think of more and more ways to optimize all the stuff that's slowing things down. And we'll talk in a minute about something you've got to do if you want to understand what's slowing your site down. Taking spitball guesses at it is not very efficient. Another thing that can have a huge effect is people using old browsers on your site. I mean, old browsers are just not optimized. 3 or 4 years ago, we ran into somebody using IE5 and called us up wondering why they were having such a problem in their boardroom with the pages loading. And we were like, because you're using 20-year-old technology? But I mean, come on. Now that was a very extreme example, but even, Chrome updates like once every 15 minutes or something. So out-of-date browsers will cause speed impacts, and it's something you need to be cognizant of. And at some point, we finally there are a couple of apps that I've worked on where we said, all right, look, if you're not at least this version on this browser, you can't run our site.
Well, I mean, everybody does that.
Yeah. So, but be aware, if people use old browsers, that can cause speed issues, and they're not your issues. But you need to understand where the speed things are coming from. Slow mobile device connections also can, if somebody's running on 0.5G, running on an old 800 megahertz system with their phone, that can cause your site to run slow. And again, not really your issue. But if you have customers calling you up saying, why is it slow? Well, one of the things you want, how are you connecting to it?
Yeah, it depends on what percentage of your customers are doing that. Like, I've seen a fair amount of outliers.
Yeah.
I'm just like, well, what can you do?
Right. I mean, there is only so much you can do. But it's good to be aware of it, because if you've got a speed issue crop up and the issue is actually that half of your people are using slow mobile connections or old browsers, you shouldn't spend your time trying to track that down, because there's nothing you can do about it. And another thing that's a big deal in how you tackle speed issues and how you identify them is making sure that you've got the right server or hosting for what you're doing. So should you be using a shared or a VPS or a dedicated server, or go serverless now, or there's a cost performance tightrope you kind of have to walk there, and having the wrong one for your application can really cause some speed issues. So what's the number one thing you use to identify speed issues?
Well, it's listed as the next thing in here, but it's what I use too. It's an APM, an application performance monitoring tool.
Right. So if you're going to track down systemic speed issues in a large app, and I'm talking about, this is more than something you wrote for your company of 3 people internally, you probably won't have a lot of speed issues there. But if this is a public app and you've got clients and people that use it and depend on it, you need to have an APM to monitor this stuff, because it's going to tell you when you've got slow queries, when you've got N+1s, when you've got problems with memory overutilization, when your CPUs are getting dogged, when, all this stuff. And it's going to give you graphs, and it's going to show you, hey, look, right here is a problem. You need to go fix this. And when your site crashes, which hopefully it doesn't, but they do, you can use that as a post-mortem and say, okay, what went wrong? How do I fix it? And how do I prevent this from happening again? You have to have those. And the APMs are things like Datadog and AppSignal and New Relic and all those, that family of stuff. We did a show on those, or that included those.
Handling,
right?
We talked about, that's one of the things they do, but the main thing they do is
this,
monitoring your application's performance.
Right. And there's links in the description below for a bunch of different ones, ones that I've used. And there are literally, like, I did a Google search for APMs specifically for Rails, and there were like pages of them. So they're not hard to find, but it's hard to kind of sift through and figure out which one is the right one for you.
Yeah, and the key thing is they help you identify what the bottleneck is. So it shows you, hey, this particular page is taking 1.5 seconds. So you can actually look at it and say, okay, what part of the code is causing it to run? Is it the query? Is it the render of the layout, for example? What part of the code is causing that delay? Is it calling out to a third-party service to pull back some data?
Right. And a lot of these APMs will actually let you, they'll set up a tree for it and say, here's the call that's going real slow. And let's dig down into it. And here's the part of that, it's calling this, which is calling this, which is calling this. And oh, wow, look, way down here is this 10-second SQL query that I probably never would have found without this APM. But using an APM, a lot of times you can track through those things really fast. And so you don't spend a lot of time guessing and spitballing what's going on. And that's important. So, as of now, what are the gold standards for page speed? And also, why are those gold standards for page speed? So, you want to have the gold standards are kind of, and this is, again, a generalization, but this is kind of what you shoot for if you're in big shops. Less than 100 milliseconds of first display. So if I hit the go button on my browser, within 100 milliseconds, I have something on my screen from your site. And then less than 2,500 milliseconds or 2.5 seconds for the full page to load and be done. That's what you shoot for. Can you do that? Not a lot of times, but if you're constantly shooting for that, you'll get close. But why is that important? Why do we care? Who cares?
I'm sorry. I don't know sometimes when you're speaking rhetorically to the audience or you're talking to me. If you're talking to me, I mean, basically me. Okay. So basically, if your site doesn't respond that fast, it's that 100 millisecond mark is the point at which psychologically or how people think they get the impression, okay, the site is slow. If it's not returning something within that time, they're thinking, okay, this is slow. And then that has, drawn effects to, okay, it doesn't look like the company knows what it's doing, or, down from there.
Right. And now, to be fair, these numbers are a bit plucked because, and they're a little over ambitious. All the studies that I've seen and the write-ups I've looked at on this stuff and through the years, and this has gone down over the past 10 years as well.
What do you mean gone down?
It used to, the gold standards used to be a lot higher, like 500 millisecond first load speeds, which is understandable because technology has just gotten faster. The infrastructure has just gotten faster. So, I mean, people are coming to expect faster. What most sites, the reading that I've done and the research I've looked at, what most sites end up getting to is usually averaging around 200 millisecond first display speeds. So you'll have some pages that'll hit 100, little simple ones. Have some pages that go longer, big complicated database pulling things. But a lot of it kind of centers around the 200 millisecond mark. And at that speed, the difference between 100 milliseconds and 200 milliseconds is so fast that it's almost imperceptible difference to a human being. Because I think 100 milliseconds is about an eye blink or something like that. So that difference, if you go to 200 milliseconds, is not making a lot of psychological impact on people. So when we say those numbers, there's some wiggle room there, but that's kind of, we push and push and push until we get as close to 100 milliseconds as we can. And if we ever hit that, we stop working on that part because it's fast enough. We don't need it any faster than that.
Now, are you sure that 100 milliseconds was for the first display? That's not for the whole page load?
Well, it's for the visible page load. So when I say full page load, what I'm talking about is all the JavaScripts have loaded in, all the image caches have been pulled up, all the stuff off the under the fold has been brought in. So a lot of what they were talking about is 100 milliseconds for what I can see. And they also left some wiggle room in there for things like asynchronous loads of certain images and bits and pieces. As long as I see something happening, it's fine. What I don't want to see is just spinning and spinning and spinning. Because there's a whole lot of crap you got to load after you get a first display to somebody. And the reason there's a differentiation even between these things is because there's a big difference if I load JavaScript in the header tag or if I load JavaScript at the end of my display, depending on what my JavaScript does. So that JavaScript, it could take two of the 2.5 seconds for my page load. So if I do that at the end, I've already displayed stuff to people and they're not even aware that that's going on a lot of times.
Man, that's a lot of JavaScript.
I mean, that's a bit of an extreme example, but I mean, it, you know, that kind of stuff can make a difference. So we kind of know generally what things can affect website speed from an infrastructure standpoint. And we kind of know generally what we're shooting for from a performance standpoint. How do we get there? So we're going to go through a lot of different things, and these are going to be generalized. And you need to understand too that how you attack this stuff varies greatly on whether you're using an in-house hosting, whether you're hosting your own site, or whether you're using a cloud service. I would venture to guess that most people don't use in-house hosting anymore, unless you're just a gigantic company. It's just not worth it. The prices of cloud hosting is so low now that it's just simply not worth trying to maintain it yourself. So we're going to go from a standpoint of that's what we're doing is we're hosting in the cloud, you know, Amazon or DigitalOcean or something like that. So the first thing that, well, one of the most common things that I run into when I'm looking at this stuff, and believe me, I try to stay away from this stuff as much as I can, but sometimes I have to look at it. And the most common thing I see is memory utilization shooting up, just going through the roof. There are 1,000 different reasons that can happen, but the fastest path to get around that and buy yourself some time is increase your memory. Now that's not a sustainable model forever, but if you all of a sudden have a memory spike or a traffic spike or something, you can throw some memory at it to buy yourself some time to trim things down so your site doesn't crash. So usually with the APMs, people will have memory utilization notifications. So if my memory
Easy for you to say.
It really wasn't. If my memory utilization goes above 75%, start shooting me emails and say, hey, take a look at your APM graphs. You got something going on here. And that's important because if you run out of memory, I can't think of an instance where you'd run out of memory and your server wouldn't crash. That's going to happen. So what other things can you do to deal with memory overutilization?
Well, I mean, when you start running out of memory, one, you have to deal with the current issue. And if you do have the ability, like you said, to upgrade the server to put it to allow it to have more memory, that is the short-term solution to go to. But what I've seen in the wild is that people say, okay, what the heck happened? And they look at their deployments and can they tie this increase in memory utilization to a deployment? Okay, what happened in that deployment? Did Joe put in an n+1 query and selecting all the columns from a huge table that's now hogging all the memory? Or your memory has spiked because of that? Like, all right,
Joe, you
let's
dink.
let's rewrite the query to pull less data that will populate the memory of the application.
Right. And this
Or there
goes
may
back
be
to,
some other reason. Maybe you installed a gem. Sorry, this is Ruby wise. You installed some library in Ruby. It would be a gem or some package or something that now suddenly your memory usage has spiked up more than you anticipated.
right. And, a lot of this goes back to once you identify, you use the APMs to identify, hey, we've got a memory problem. More often than not, you're going to have a database or a code issue going on. It's not a hardware issue. But where you find it is looking at the infrastructure monitoring. And it says, hey, my hardware is getting panicked here. You need to go look at the other bits and see what you're doing.
Yeah. Or it could very well be you have an instance that's, if it's only one instance, maybe you have that particular instance, maybe it has some sort of a hardware failure. Maybe a memory module went bad. You don't have any insight to that if you're using something like AWS or whatnot. You don't know, but it could actually be hardware, but rarely that is the case.
Yeah, and if you're doing in-house hosting, one thing you want to look at is make sure that it's not that memory utilization went up, it's that memory capacity didn't go down. You had a memory stick go bad or something. Because I've had that happen, and it sucks. So another thing that you can do there is if things start running slow, because you can get this real bad spike of traffic. You're running some special at Christmas time, and all of a sudden your traffic quadruples overnight. You can also throw bigger, better, more powerful CPUs at it. That's another, in most web cloud hosting systems, you can just upgrade the CPUs that you've got. Give me more or give me better ones, or, so that's another path to kind of buying yourself some time to figure out how to deal with that kind of traffic.
Yeah, and your APMs or your whatever you're using to monitor your hardware should tell you, hey, is it you're using up your memory? Then you can look at APM to tell you, okay, is this a new problem? This is a problem that's been rising up slowly. And then you can figure out how you want to resolve it. Or it can tell you, hey, if you're ever hitting 80% CPU utilization, you definitely want to do something about that.
Yeah.
And, the question is, why is that happening? If it's a temporary spike, is it a result of some issue that you need to address? Or is it something that's just been slowly increasing and you've hit that mark and basically, okay, well, maybe we need to get a larger server because of the amount of traffic.
Right. All right. So I'll let you tackle the next two because you know more about those than me.
Oh, you mean about load balancing?
Yeah.
Okay. Well, basically, once you start needing to have more than one server, there's two benefits of doing load balancing. You would want to look at that if you're going to want redundancy. So for example, my application set up such that the DNS actually points to two different Nginx servers, so that if the DNS routing to one Nginx server fails, it'll fail over to the other one so the application can keep running. But the other benefit of load balancing is it can balance the traffic between the two Nginx servers. So basically you get double the performance essentially. So basically you can now support scaling out as opposed to just scaling up a single server. And then I even load balance between application servers. So Nginx actually has, as its backend, it points to two different application servers. So it can serve it to either one of two application servers. So again, that gives you redundancy as well as enables you to scale out and have as many other application servers as you want. In terms, you could have an application server farm or an Nginx farm.
And that's a good thing to think about, even if you're kind of small, but you're expecting big growth. If you set up load balancing, then if you get those massive spikes, it's usually not terribly difficult to spin up another pod or S3 instance or whatever to handle that traffic. So if you already have that architecture set up, that's an even faster path to dealing with and buying yourself some time.
Yeah, and once you, yeah, exactly. So now I have the option, I can scale up, get larger instances, or I can scale out and just have more instances. Because, and the other thing I've noticed is that this has really helped doing certain deploys that would normally bring down the system, or certain upgrades I needed to do because of the load balancing. I'm able to say, okay, turn off the traffic to this instance. I'll do some updates to it now. Okay, put the traffic back. So basically the app keeps running when normally I would have to bring it down, at least for a short period of time.
Right. And that's common practice in a lot of the big apps. Like we do that because, we'll have 20 pods running to serve this stuff, and we don't want to take everybody down. We can't, because it's, somebody's using our stuff 24/7. So when we do updates, we do rolling updates. So we, this pod goes, then this pod goes, and this pod goes. So we've always got something that can communicate, and then they all get updated eventually, but nothing ever goes down.
Yeah. And we're getting in a little bit into like high availability, but in terms of performance, it basically gives you the option to not only scale up, get larger instances, but also scale out across, multiple instances. So that's the benefit of load balancing. The other way to fix, if you're having an issue where you're needing to serve a lot of large files or even images or things of that nature, using a CDN, a content distribution network service, that can help you not have your infrastructure or your application servers have that burden. You've put that burden on the CDN, and plus they, geolocate near where your customers are, that content. So that if, say, you have a customer in Singapore, well, they would pull a lot of the large files, large images, say your JS and your CSS bundle from the CDN, and just pull what they need from your application servers that may exist in Europe or US or wherever it may be. So that's a benefit of performance from their perception. Things load faster, as well as your application servers less burdened. So if you can use a CDN, that's the benefits of helping your performance.
Right. And it's kind of the same concept of the reason my ISP is here instead of in Bangkok or somewhere. It wouldn't do me any good to have an ISP in Europe, because I'm not in Europe. So why have my stuff being pulled from a server in Europe? All my big images. That's so same concept, but for big files. So there's this next one is a little more difficult to do depending on what your app does. But whenever possible, deliver static files. They're easier to cache, they're faster to transmit, your server doesn't have to do as much work. So, things like CSS, JavaScript, images, that kind of stuff, deliver them statically. If you can deliver static HTML, that's faster. Most actual apps that do anything in the web can't do that for the HTML a lot. So you have to do like fragment caching and things so that only parts of the site, the page get updated and that kind of stuff. But Static files are going to work a lot better, faster from a speed perspective. So whenever possible, deliver static stuff. Also, if they're not changing, they can be cached. So you don't blow the cache out if you don't change the stuff, which means they can be loaded faster once they've gotten them the first time. Another thing that you should always be doing is using compression and minification on your, especially your CSS and your JavaScript files. So minification is where they take the nice pretty layouts that you've got for your CSS, you know, where it's all nice and spaced out and indented and stuff, and they just take out all the spacing and jam it together. But when you're delivering it to a web browser, it doesn't need it to be pretty. It needs it to be small. So getting rid of all that extra cruft, the spacing and the tabs and all those characters makes a big difference. So you should be delivering minified versions of your CSS and your JavaScript, and you should also compress them. Most HTTP servers either by default do compression or at least easily support compression, like gzip or something. So you should be implementing that. I can't think of a reason not to.
And most frameworks also support this compression minification.
Finally got you with one.
So like Rails, of course, does it. And yeah, and even Phoenix with Elixir, I know, has a means to do it. So I imagine most frameworks have some ability or use some tool to be able to do this for you.
Right. Yeah, I can't think of modern web development frameworks should all have this. It's pretty much ubiquitous now. It should be. If you're using a framework that doesn't have this, you might think.
Or I mean, if you don't, because there are bare bone frameworks, but if you don't, then you got to roll your own.
Right. But
or find a library that does it for you.
Right. But that should be something you can find, and you definitely would need to do that. So another big thing, and this takes a little more thought and planning, but reducing the number of HTTP requests. When I say HTTP, I mean HTTPS, because everybody runs on SSL now. Well, TLS, but HTTPS, nobody runs HTTP sites anymore. And if you do, shame on you. Because S is faster anyway. But reducing the number of requests will make your site faster, because if I have to deliver 4 files and I have to deliver them in 4 requests as opposed to 1 request, while the size of the files isn't different, the time to make the request, do the handshake, do all the overhead of the connection is happening more. So the fewer requests I do, the faster my site goes. Now, unfortunately,
and I think HTTP 1.1, there's only so many you can do concurrently or something like that.
Right. So yeah, one of the things that is becoming a thing to do now is migrating to your site to HTTP 2, because you can do much bigger file sends, multiple file sends on the same request, which has a big impact. So, and you know, switching to HTTP 2 typically isn't as difficult as it sounds, but it's not something, I mean, you have to look at how your hosting service is typically the one that's going to be in charge of that. So you'll have to get instruction from them on how to do it. Most of them have documentation on here's how you migrate, but I would encourage you to check out the HTTP2 spec, because there are a number of things in there that can help with performance, as well as a bunch of other stuff. But being able to send multiple files in one request is just a big bonus right up front. another thing that you had kind of mentioned before is image size. So if you're designing a site that's got images in it, don't design only for Retina displays. Not everybody uses Retina displays. You don't need the super huge megapixel image for everybody, because it won't make any difference. You should be setting up for responsive image sizes. So if I've got a 30-inch monitor, I get one size because it's responsive. If I'm looking at it on my phone, it sends me another size image because I don't need, a 1020 by 480 or whatever image. I don't need it that big. 1920 by 1080. What is wrong with me? Hey. Anyway, lots of things, but that's a whole other show. But you should be using responsive image sizes because images take a long time to download. They're big files most of the time. So the smaller you make them, the better you are. And one of the things that I've seen a lot of people fall into the trap is, let's just get the biggest image we can and we'll just reduce it to whatever size we need it. That's not a good way to do things. You should deliver the image.
You're saying they do that with CSS,
right?
So you only have one. Okay.
Yeah.
As opposed to generating 3 or 4 variations, and then the CSS using one of those 1 through 4 variations. They're literally just saying, "Hey, shrink the size down to."
Right. Make the image this size.
Yeah.
Because then I have to. Then what I have to do is everybody has to get the biggest one.
Yeah. The browser has to download it and then resize it, but it pays for that download expense.
Right. Not only that, but then you have to have the computations to actually resize that image for display. So, you got kind of a double whammy there. Now that computation isn't terribly expensive, but when we're shooting at 100 milliseconds, 5 milliseconds is a deal.
Right. But if you're talking about an older mobile device, number one, it can't render it. Number two, it's got to download massive gob of an image. And 3, then it has to render it.
Right, exactly. So, images are one of the bigger things that you're going to deliver to your end users. So making sure those are optimized is worthwhile. And this
is why a lot of people use CDNs. Because there are also CDNs that actually let you resize the image on the fly. So you don't have to upload it, but you can just request an image of this size and it actually generates it for you.
Right.
And then caches that result.
Right. And that's really important when your app allows your users to submit images for display, because they're going to submit whatever size they have. So if you've got something on the back end if you don't have something on the back end that's going to resize that and make different sizes of it automatically, you're going to be delivering that huge image to everybody that looks at it. So, it's paying attention to image sizes and getting your image sizes right is a big deal. And you should be using responsive images depending on the size of the display. So another big thing that you should be doing, in addition to APMs, is running load tests to catch issues before they're a problem. We do this routinely. We run big load tests. We have just a load test server, and we run big load tests, and a lot of companies do this, to make sure that we haven't made a massive snafu and we're getting ready to release something to our clients that's just going to blow everybody up. Load testing is not fun. Well, at least according to anybody I've ever talked to, and I've never had fun with it. I don't like it, but it's very, very necessary. And once you set it up, most of the time you can just run it and you're done. So every time you may have to tweak a test or two, but most of the time, just like your RSpec tests or test units or cucumbers or whatever you got running, you may have to tweak a test or two every time, but most of the time you just run your test suite, and if nothing breaks, hooray. There's tons of options out there, just like APMs. There's a ton of people doing this. So things like JMeter, Akamai Cloud Test, Blaze Meter, Load Focus. There's gobs of them. They're not hard to find. JMeter, you write your own tests, and it's kind of local hosted. A lot of these other ones are cloud hosted, so you just set the tests up there. But I've used JMeter quite a bit, and it does a pretty good job for some things. But the pay for cloud hosted tests are usually a little better at being more thorough with less work. So just keep that in mind. But I would highly recommend doing load testing on your stuff if you expect to have more than a couple hundred people ever looking at your site.
Or if you would want to do it to get a baseline. And then anytime that you think you're going to be potentially impacting the scalability of your application, then it would definitely be a good thing to run through again.
Right. Well, and also if you're trying to fix a speed issue, you can't know if you're going to fix it, if you're fixing it, unless you test it. And the only way to test that is really to load test in most cases. So you got to get your benchmark, you make your fix, and then you say, okay, yeah, this made it better, or I just wasted 4 hours of my life doing nothing.
Well, right. I mean, so, there, you have a problem. So if you have a problem, then you could tackle it that way. I'm saying, like, in terms of doing it preemptively, when is it appropriate to do that? And,
right.
Because a lot of people don't do a load test before every deployment, or at least I haven't heard of that. But I've heard of, hey, we're doing something that has the potential to impact on a broad scope performance. So let's do a load test, compare it to a previous baseline to see how we are.
Right. Yeah, and we don't do, most people don't do, and we don't do every deployment. Like patches and stuff like that, we won't load test typically, unless we know that there's something that could impact speed. But if we do, significant deployments, we usually will run load tests against them. All right, so why don't you talk a little bit about the servers, the fun stuff that I just close my eyes when I see Nginx coming. I just put my hands over my eyes, turn around, and run away, and hope I don't hit a tree.
Well, I mean, the thing about it is that, I just get the servers that I think are going to be adequate for the load, and, apply it on there. And if it needs more, then you bump up the server size. I mean, that's what I do today. In terms of configuration, I really do minimal configuration unless I start to see that there's some sort of bottleneck that is not reflected in high memory or CPU. So what I mean by that is, like, I'm using JMeter and I'm putting a load on the system and the CPU is at 5%, but I can't get any more concurrent requests. Okay, something's fishy. Right. So then I say, then you start looking at, some of your Nginx parameters to see, okay, what can be added here, or even kernel modifications to do to Ubuntu. This is assuming you're running your own Nginx server. Not a lot of people do that. The other option, of course, is to just outsource it to, like, the cloud providers, because they have their own front ends, like CloudFront. They can be your front end to load balancers in AWS, so you don't even have to have your own server. But if you are trying to optimize it and you're seeing, if you are running your own and you're seeing this type of discrepancy where you can't push any more throughput through or can't get any more requests per second up, but yet your CPU's not spiking and your memory's not spiking, then there's probably some configuration that needs to be bumped up. And once you do that, then suddenly, boom, now you're using 80% of the CPU. So now you know that you've resolved, whatever the issue is.
Right. And, like you mentioned, typically you don't need to run your own HTTP server like Nginx or something like that. However, I would highly recommend that everybody set one up so that you understand what they do, because this is where your load balancing comes from. This is where your proxies happen. This is where your gzip compression. This is where your routing to SSL and non-SSL and your redirects and all that stuff goes on. So understanding how that works is a good idea. I'm not saying you need to be an Nginx expert unless you work at one of these places, but you should have a basic understanding about how HTTP servers work and how these engines operate and how the requests go back and forth, because it's just going to make it easier for you to understand what you need to change in your program, in your code, and in your database to help that be better at what it does.
Yeah, and everything you mentioned, HTTP to HTTPS redirection, and all of those are little things you can click in, say, AWS to enable.
Right. Yeah, exactly. Yeah, there's no, most people aren't ever going to have to manage these things directly. I'm just a big believer in kind of at least exposing yourself to the back end of it so you get an understanding of how it works, because it'll help you just understand what you need to do on your end to help that stuff along. If you know what it is. Like I dread looking at Nginx config files. It breaks my brain, but I've gotten in there and played with it because I wanted to understand what kind of things happened in there. So,
yep. I mean, definitely an educational. And if you choose to go that route, you would save a little bit of money.
Right. Well,
as opposed to someone, well,
depends on how much the opportunity cost is, but
True, right. You would save money in ongoing costs, but you may end up paying a lot on the back end if you misconfigure something
right
for a production site.
Yeah. And it's so, yeah, the costs of getting someone else to manage that for you is so low now, relatively speaking, that I don't think it's worth running your own unless, well, I just, other than as an experiment and a learning platform, I don't see a good reason to do it yourself. But I do highly recommend that you experiment and learn on an internal platform, play with them.
Now, we'll say this is part of the reason that I still do some of this for some of my things, is I don't want to be locked in to a particular vendor. So, because unfortunately there are no like open source tools that do all of this for you with a point and click interface.
Mm-hmm.
You have to go with, all right, if you're going to be using AWS, you got to use the, AWS has it, there's a certain way they do it and certain way that they set it up. If I wanted, I'd have to learn an entirely new way to do it if I wanted to move to, say, Microsoft Azure or Google's hosting.
Mm-hmm.
So, that's how they kind of do their lock-in.
Right. And that, that's something you have to be careful of through a lot of this stuff we've talked about too, is there is a cost to having somebody else do it. We talked about having to reach out to third parties because they get slow. Well, that can happen to your hosting too. It can happen to your Nginx. They misconfigure something or something goes wrong and things just get really slow. So you do have to be cognizant of the fact that if you go with a third party for something, you are relying on them to do it right. Most of the time, that's not an
times
issue.
out of 10, they're gonna do it right.
Right. Yeah.
Of course, or probably higher percentage than that, but
right. But you also have to be cognizant of the fact that if for some reason you learn that system and then it goes away and you have to switch to another system, you have to learn a whole new system. So, just keep that stuff in the back of your mind. Now, I'm not saying you shouldn't do it. Most of the time, it's well worth doing that because the benefits are just way higher than the potential costs. But just keep that in mind, that there are potential costs with doing that stuff. But nobody's ever going to get me to run my own Nginx server. I'm not doing it. I'll just go to pen and paper before I do that. So anyway, that was the end of our performance series. I'm sure in the future we'll have more things about speed and stuff, but we'll probably get into more specific things. This has been kind of a broad overview of all the performance areas that you want to look at. Next week, what are we doing next week?
Actually, we were going to move another episode up. It's kind of following on some of the things that David Hannemeyer Hansen, who kind of designed the Rails application framework, has talked about the new way he wants to take Rails 7 in terms of handling JavaScript. And he has a post he recently released talking about the modern web apps without JavaScript bundling and transpiling. So I kind of wanted to have a discussion on that. So it's won't be 100% Rails specific, but it'll be a lot talking about JavaScript, how it's used in frameworks, a little bit about the history, and then kind of where the direction it looks like they're talking about heading, and wanted to get your thoughts.
I try not to think if I can help it.
Thoughts to see. No.
Yeah. Yeah, viewers, I don't think. They think. All right, so we will be back here next Wednesday, 8 p.m. Eastern Time. And that'll be, sometime in September. Time is flying.
Oh, boy.
Woo. So hope you guys enjoyed that. If you did, please make sure and mash that like button. Also, if you want to see more of these and be notified when they go live, when we go live, they go live. I'm part of this. Sure, we go live. Just subscribe or follow or whichever platform. We're on Twitch and YouTube. Yeah, the other guys that do video stuff.
Head on over to rubberduckdevshow.com. You can put in your email and we'll send you a notification.
Yep.
As well.
So we got all kinds of fun, nifty things going on behind the scenes. We will have some new little goodies coming out before too long, but we'll spoil those when it's time to spoil them. And well, I guess that's it. We're up on time, so hope you guys enjoyed that. We will see you next week, and until then, happy programming. Bye.
Yep. Bye.